Okay, so welcome back, and now we're going to talk about the case of SSA, side-side angle. So there are cases where you get what we call an ambiguous triangle, okay, where there may be no solution, one solution, or two solutions, okay? And so I've given an example of each one here on the board. I'm going to walk through each case for you. So when you're dealing with the SSA example or situation, you got to be aware that there may not be any solution. There might not be a triangle. It might not be a real triangle. It may have exactly one answer, okay? Or there may be two possible solutions, two possible triangles, okay? So in this case here, remember, side-side angle is where you know two of the sides and then one of the angles opposite one of those sides, okay? So, in this case here, let's say we have, which angle do we want? Well, you know what, it doesn't matter. So let's say we have A, B, and C, right? So we have C, so A, B, C. Okay, now, in this case here, when we have side-side angle, there's a couple of things we have to look at. We have to look at the relationship between the length of this side A and the length of the adjacent side B. And also the relationship of A to the relationship of the altitude h. Okay? So, in this case here, if the length of A is less than by B, right? If these two sides is such that the relationship between A and B is this, A is less than B, then that tells us there is no triangle. So therefore, no solution to the triangle. Well, it's not even a triangle, right? So we can't even talk about solutions. Now, what if A is what? If A, well, let's see here. Actually, this should be A is less than H. Right? So if A is less than H, the altitude, that's what I meant to say. Then we have no triangle, right? So keep in mind, and this is the way I normally, when I think about these things, think about there's a hinge at the top here. And then A is like a rope, or like a bar, like a rod that just hangs there and can swing, right? Like a pendulum. And the hinge here is right at angle C. And there's a hinge there that allows the line segment, this A, to swing. So now if it can swing without hitting this side C, then it's not a triangle. Right? A has to be long enough to be able to intersect C, right? So if A is less than the altitude, it's going to swing and it's not going to intersect this side at all. So we don't have a triangle. So that's why if A is less than H, then we don't have a triangle. Now, if A is equal to H, then guess what? This is going to swing, but it's only going to intersect at one point. right there at the bottom, right? So it's just long enough that when it swings, it's going to swing down and hit right at the altitude. And so in that case, we get a right triangle. And there's only one triangle, and that triangle is a right triangle. So what does that mean? That means that A, now let me write this way. So A is equal to H. If A is equal to H, then we have a right triangle. Okay, now, the next two cases are where, again, we want to make sure that we understand the relationship here. So now here, in this case, A is less than B, but it's also greater than the altitude. So what does it mean? That means that, hey, A is long enough that it's going to, what? Intersect this side in two places because it's greater than H, so it's going to swing down below here, so it's going to intersect somewhere over here, and it's going to come down and it's going to swing back up. But because A is less than B, it's going to intersect somewhere over here on the other side of H. So this is going to create two triangles, two possible triangles. I could have a triangle that's what we call an obtuse triangle, right? It can have an obtuse triangle where this is B right here, right? So we could have B right here. So we could have the triangle ABC, which is an obtuse triangle. Or we could have an angle B over here where we end up having an acute triangle. So in this case, there are going to be two possible solutions. Okay? This is where it's ambiguous. When we're in this situation, we don't know, based on just what we're given, what triangle we're dealing with. So again, we'll have two possible triangles to solve. Okay? So that means we have two triangles. Okay? Now the last one, we only have one triangle, right? So here we have two possible triangles. Now, in this case, we have what? In this case, A is bigger than B. That means if we extend C in either direction, what's going to happen is A is going to swing down, right, from here, and it's going to swing all the way. It's going to be, since A is longer than B, it's going to swing and to completely miss C. Okay? So that means that there's only one possible triangle. And it's an obtuse triangle. Okay? So in this case here, this case and this case, there are only one triangle. In this case, you have a right triangle. In this case, you have an obtuse triangle. In this case here, you have no triangle. And in this case here, this is the ambiguous case that you have two possible triangles. Okay? And so now, keep that in mind as you're solving these, because you could end up with one of these cases. So again, make sure that if you are in the situation where one of the sides that you know is larger than this side, but bigger, or excuse me, less than this side, but bigger than the altitude, then you have the ambiguous case, and you've got to solve accordingly. Okay, we'll come back and do an example.